Hey folks, in this video I want to talk about how to actually construct a hash value. After that, we're going to spend a little bit of time also to talk about basically the choice of m, right? So these are kind of things, concepts we introduced in the previous video, right? We had this idea of a hash, the idea of n and m, so we're going to talk about them a little bit more. All right, so starting off with hashes. Basically the question is, how do we produce our magic hash value? So we already said, right, that we should have something along the lines of, it's like I have an object, and from that, right, I produce an integer, which is a hash. And the way I produce that, right, is by some hash function. And so the question is, of course, how do I implement such a hash function? Here are some examples. Let's say we're trying to determine the hash for an integer. How can we do that? It's actually pretty straightforward, because if we have a number, the number is already uniquely defined by itself. Numbers are unique. Done. Right? We don't need to do any work. We don't need to do anything like with a modulus operation or transformations, adding, multiplying. We're done. Right? The hash of an integer is simply the integer itself. Pretty straightforward. All right, floating point numbers. A little bit more complicated because we have a decimal point. So we have something like 15.44321. What do we do with that? Well, there's a couple things we can do. One thing, right, is that we could try to just round it. We could basically, throw away the decimal. The problem is all of a sudden, things that are not the same look the same, right? It's like, well, 1.5 and 1.6, end up being the same thing, right? They both round to 1. Not such a good idea. So usually what happens is we actually do this kind of thing over here. And so here, right, so it's bad if I do this, right? If I do a round on, I'll just call it k. If I do a round on a number directly, then that's a little bit of a problem because I lose some precision there. Really what I want to do is basically multiply it a little bit. So let's say I have like a number, 1.2, right? What would be nice is basically, so it's not, well, what'll help us, it's not necessarily a nice thing because it'll slow us down also a bit, but basically just multiply it, right? So you can imagine you multiply this by 10 and you get back out, 120. And so all of a sudden, or 12. So all of a sudden you get, basically you get a whole number, right? Even though you had a fractional point, it's like you're just pushing everything to the left. So you're raising up your decimals and you're making them, a whole number. So you can do that. The only problem is that sometimes if you have very large numbers, it's like, well, you don't really have the space to do that, right? If all of a sudden, you're kind of having, a very, very large float that's kind of, occupying all the bits that are in the number, well, then if you try to multiply something, you're going to have some sort of an overflow issue, okay? So that can be problematic. Maybe there's something else. Maybe you need to basically hash the thing twice. You could hash the significant, you can basically just hash to the left of the decimal and then to the right of the decimal. So, all right. Now I go to stuff that's even more complicated. First off, strings. So a string basically is a series of characters. And so the way we actually want to do that is by doing a hash that's, kind of takes into account every single different character. So over here, I'm starting with some hash value. So this is hash of 0. And this hash value, I'm basically going to accumulate into it the character, right, if you would, of each character in that string. When I say character the first time, right, basically my meaning is like the information inside of it, right? I want to compute a value, right, a hash value for this string such that it's impacted by any character in that string, right? So if I change one thing, or if I change, A to B, right, or add the exclamation point at the end, if I do anything, then I should have a change in the overall value, right? So I want to basically have that hash impacted by everything. And so what we'll do is basically have a loop here, right? This next line is a loop. To walk over and look at every character in turn, right, inside of my string, and do a hash operation on it. So let's take a look at the code there. Basically what we have, right, is this thing over here, which says 31 times hash. So it's like, oh, there's an existing hash. I'm basically going to turn it, right? So there's a multiplication there happening by a prime number, and somehow what you should think of that as, should think of that as is basically looking at a number and kind of just shifting around the bits. It's like you're turning something, right? You can imagine you have a shovel, right, and you're turning a pile of dirt, right? You're just kind of mixing it up. That's what you're doing here. When you're multiplying by that prime, it's like you're scattering your bits kind of a little bit to the left, right? Assuming that your left is your most significant bit. Eventually, right, some of the discussions we'll have in here are basically about the different kind of like the bit layouts of numbers, because that will be important for us in terms of basically preserving the identity of things. So yeah, we basically start with the previous hash, turn it up a little bit, and then add our current character, right? So it's like we're adding some knowledge or some information from the character we're currently looking at. So it's like we start at character 0, then character 1, then character 2, character 3. And because it's in a loop, right, basically every time you're adding in a character, you also have the step of you're adding that character to the previous hash. The previous hash once it's been mixed up a little bit. And then at the end, right, we have basically a modulus m, which we don't strictly need here. It depends on whether or not we're going to constrain ourselves to an m that can fit into a real array or an m that can be anything. In terms of an m that could be anything, maybe we can just leave this out, not worry about this too much. All right, so this at least gets me to an integer number, right, that represents basically everything in a string, right? If I were to change any letter in that string, it would change something, right, in that number that I produce. All right, last one here is compound types. So basically, it's like I have a key, right, that has a compound data type, meaning that there's different pieces in it. So for example, right, maybe I have something that has area, exchange, extension. How do I generate a hash for something that has different things in it? Well, just kind of take the approach of that loop. So over here, it's like, well, we're going to take, the area, which is, some number multiplied by something, add an exchange, right? Then do a modulus, then do another multiplication, do another add. Basically, doing this kind of sequence of, multiplications by a certain number, right? And then as it gets too big, maybe throwing in a modulus to, kind of wrap it around, get it to be a little bit smaller, so that we don't start losing information. We don't start losing kind of information, completely right from the end of it, right? Because if we let our number go too big, it's like, well, our bits, we don't have any bits to store stuff. So we don't want to have an overflow issue there. So yeah, again, somehow, right, the idea is this. If I have something, right, I have a piece of data, I want to generate a number by, looking at each component of it, right? So here it's like the string, I looked at each letter. For the compound type below, I look for each, that would have been the equivalent of basically member variables. And I basically had this process where I add them all up with some multiplication in there, right? If I do that, then I'll end up generating kind of a, magic number, right, that has that identity of the things that I'm looking at. All right, so the second thing I want to talk about in this video is kind of the value of m. Because I talked about it here, I was like, oh, there's m in practice versus m in real. So m, right, is basically going to be our size of an array. Now, if I were to generate a hash value just from scratch and not have to worry about storing it anywhere, then I don't have to care about m. I'm just immediately done, right? I can have any possible number that I want be there, right? It's fine, it's all good. Where I get into trouble, right, is when I have an array, right? Arrays have to be a fixed size. I can't just have them infinitely large. I have to have them some size, of size n. So what do we do? Well, it's actually going to be pretty straightforward. What we're going to do is this. We're going to see that we have a hash value, and we'll just do hash value mod m, right? So it's like whatever number you get for the hash, just shrink it down, right? Because the modulus is basically forcing you to have this number in a certain interval. So if I have some hash 12 and I have m equal 10, do 12 mod 10, I'll just only get 2 back, right? So it's like I'm basically taking my number, right, and chopping off the front, dropping some part of it, right? So that I get some value that's inside the interval, right? Because m really is defining interval, right? From 0 to m minus 1, that's the size of the array, that's where all of your elements should be put. So that, right, will kind of solve our problems, right? If we just do the modulus operation, that'll kind of, get all of our keys and fit them down into one place. And we'll have to come back to this, though, because this, right, you can probably guess, this may cause some sort of a collision, right? If I'm kind of, making things fit into the smaller interval, there's basically this chance that two things will end up, after the modulus having the same value. There's actually almost like 100% chance of that happening. So we will have to talk about that later on. That's actually what we're going to need to do when we talk. Well, that's actually the reason we're going to have this huge discussion on a collision resolution, because there needs to be something we do when we have some sort of two things, right, that basically match up inside of that array. All right. So anyways, the question here, right, somehow, what should m be? So m cannot really be an arbitrary selection. So let's take a look actually on the right-hand side. So I have basically a series of keys kind of over here, right? So these are some possible keys. And then I have basically a modulus operation. So here is mod 100. And so the question here, right, you can think to yourself is, how many collisions occur? So just looking at this, I can see a few, right? So I have, let's see, 2 and 2, 7 and 7, 1, 1, 1. Is that all of them? That might be all of them. Fair number of collisions, okay? That's if I picked M1. I still have a couple collisions, but in general, I've reduced a lot of them. So over here, it's like, well, we had maybe, around 7 different collisions, versus over here, I only had 1. That's a pretty good upgrade, right? So why the difference? So the problem with picking a hash that looks like something like m equals 100 is that you are being biased towards a particular part of your number. So here it's like, well, these are numbers like 212, 618, so on and so forth. When you do that mod 100, it's like you're throwing away the first part, right? So it's like all of a sudden, all of this row just vanishes. So any uniqueness, right, any identity that belongs to that digit place is simply lost at one go, right? It's just like I'm looking at this thing here, all these collisions occur, okay? And really, right, what I don't want to do, right, is this thing where it's like, well, I'm just throwing away part of my input, right? I'm throwing away part of the key. I shouldn't do that. Whatever number I produce, right, I want to basically have the character of what is the input, right? What is that key? So that would be a bad idea. So M97, M97, I guess the first observation here is this is actually a prime. And it's a little bit, too high level for us to go into in this course, but basically, if you pick a prime number, you'll have more of a, what looks almost like an even sampling of or random sampling of bits in your input, right? So it's like here, we're basically throwing away, part of our number, right? When we have something that looks prime, we're not gonna be throwing away a particular part. We're going to be throwing away information, sure, because it's a modulus, but we're not going to be throwing away a particular position in the actual number, right? We're going to be kind of sampling and throwing away a bit here, a bit there, a bit there. We're not going to be end up, just throwing away this entire segment, right? So it's like, it's as if, right? This is a little bit high level and not strictly true, but what we want to do, right? And imagine these are the same length, is basically, it would be better, right? So instead of having this, right, throwing away, the entirety of the front of this, throw away like a little bit here, a little bit here, a little bit here, a little bit here, right? So if I could throw away from different positions, maybe I would have a little bit better luck, right? Rather than just throwing away a whole part of it. All right. So basically, I pick a prime, right, for your m value. The ones you want to avoid are anything basically looks like a power 10, right? So here this is 100, or anything that looks like a power 2. Picking a power 10 value will basically take out an entire digit right in the decimal representation, which is clearly bad, but then picking a power 2 number will take out an entire digit in its base 2 representation. So, we don't want to knock out, right, any particular bit. So pick a prime, right, it'll kind of give us a good sampling. All right, so in this video, we've had some discussion on how to actually construct a hash value, right, basically construct that hash function, as well as how we decide, what should our value be for m. In the future videos, right, we'll kind of move forward again, right, the number one issue we need to kind of address at some point is going to be collision resolution.